If you do the math, like just looking at the sheer age and scale of the universe, the night sky shouldn't be dark. I mean, it really shouldn't.
No, not at all.
When you consider that the universe has been around for nearly 14 billion years, and it contains trillions of galaxies, biological evolution shouldn't be some statistical one-off. It shouldn't have only happened here on Earth.
Right. Statistically, the sky should be blindingly bright, like just filled with the exhaust of a billion alien empires.
Exactly. Which brings us right to the doorstep of the Fermi Paradox, the ultimate cosmic mystery. Given the vastness of time and space, where is everybody?
It's the question, isn't it? Because we should be seeing a bustling, noisy universe.
Yeah, astrophysicists always talk about Kardashev Type 2 or Type 3 civilizations, these hypothetical, super advanced species that have figured out how to harness the energy of entire stars.
Right, we're talking about species building giant Dyson spheres.
Wrapping solar panels around their suns or engineering megastructures that span across whole solar systems. But we look out and we don't see any of that. We point our most powerful telescopes out into the dark, we scan across the radio frequencies, and we hear absolutely nothing. The cosmos appears entirely silent.
And it creates this deeply unsettling tension, you know? It makes us wonder if we are entirely alone, or maybe if we're just incredibly early to the cosmic party.
Or worse.
Yeah, or worse. Like if there's some great filter out there that reliably wipes civilizations out before they can ever get to the point of building those massive megastructures.
Well, the source material we are diving into today offers a completely different answer to that silence. And honestly, it completely flips our fundamental understanding of what an advanced civilization even looks like.
It really does. It's a complete paradigm shift.
Today, we are looking at a deeply fascinating post from April 2026. It's by an author known as SpiralSeekr, and it's titled A Solution to the Fermi Paradox.
Such a great piece.
And our mission for this deep dive is to explore a mind-bending theory that suggests humanity has been looking for all the wrong things in all the wrong ways. Okay, let's unpack this.
So, the brilliance of this piece lies in how it identifies a massive, unexamined assumption that humanity makes about the future.
Right.
We look at our own history, extending from tribes to continents, crossing oceans, finally reaching the moon, and we naturally project that trajectory onto the cosmos.
We just assume that's what you do.
Exactly. We assume the ultimate, inevitable goal of any successful civilization is to expand outward radially. To conquer their moon, then their solar system, then neighboring stars, just spreading out like an empire on a map.
Wait, hold on. I have to push back here. Isn't exploration just, what life does?
Well,
I mean, it's literally woven into our DNA to spread, adapt, consume new resources. To say a civilization just stops expanding outward feels like betting against biology itself.
I get that. But let's look at the actual physics and thermodynamics of that biological expansion. SpiralSeekr's core thesis uses cybernetics and thermodynamics to completely dismantle that assumption.
Okay, how so?
The theory argues that moving biological life across the cosmos is just an energetic nightmare. Biological life, specifically carbon-based wetware, like us, is exceptionally fragile and terribly inefficient.
Inefficient in what way, though? Because, we managed to get to the moon just fine.
True, but think about the sheer mechanics required just to leave Earth. You have to fight an enormous gravitational well.
Right, getting out of the atmosphere.
Yeah, and this is governed by the Tsiolkovsky rocket equation, which is incredibly punishing. To carry more mass into space, you need more fuel.
But the fuel has mass.
Exactly. The fuel has mass, which means you need even more fuel just to lift the fuel. The amount of chemical energy required simply to put a small tin can of human beings into low Earth orbit is staggering.
Yeah, that makes sense.
Now scale that up. Imagine the thermodynamics of trying to move an entire civilization's worth of biological mass across light years.
I see. The math becomes exponential in the worst possible way. You're not just fighting gravity, you're hauling entire ecosystems.
Right. You can't just send the people.
You have to bring millions of gallons of water, soil, atmospheric generators, decades worth of food all across the freezing, empty void of space.
And you are doing all of that while battling constant thermodynamic decay. Deep space is incredibly hostile to complex biology.
Because of the radiation, right?
Yeah. We evolved under the protective blanket of Earth's magnetic field and atmosphere. Out in the void, you are bombarded by galactic cosmic rays. High-energy particles literally act like microscopic bullets.
Wow.
Over time, they just shatter the double helix of carbon-based DNA. Our cellular structure wasn't meant to survive out there.
It's the ultimate friction. When I was reading SpiralSeekr's breakdown of these physical constraints, an analogy clicked for me.
Oh, yeah.
Yeah, trying to move massive, fragile biological bodies across light years is like, imagine you need to share all the knowledge contained in a massive multi-story physical library with someone across the ocean.
Okay, I follow.
The biological expansion approach is insisting on physically packing up all those heavy, degrading, fragile paper books onto thousands of cargo ships, fighting the weather, the salt, the ocean to get them there.
Right.
When instead, you could just digitize the entire library and email a PDF in a fraction of a second. The source uses a phrase for this that is just perfect. Moving massive biological entities across the cosmos is structurally absurd.
It is structurally absurd. And if you want to really grasp the scale of that absurdity, consider your own daily energy expenditure.
Okay.
Think about the thousands of calories you need to consume every single day just to maintain a body temperature of 98.6 degrees, to pump blood, to digest food.
Just to exist.
Exactly. It's a massive energetic overhead just to keep the machine idling. Now multiply that caloric cost by billions of individuals.
Oh, man.
And then add the propulsion energy required to push all that meat and water to a fraction of the speed of light. The energy requirement becomes grotesque. It's a completely unscalable model for a civilization looking to survive for millions of years.
Okay, so biological space colonization is an energetic nightmare. I'm with you. But civilizations still have to grow, right?
Of course.
If physical expansion is structurally absurd, how does a hyper-advanced species continue to evolve without burning through immense physical energy? They can't just stagnate.
They don't stagnate, they optimize. A fundamental principle of advanced intelligence is that as a species evolves, it moves toward maximum computational complexity using the absolute minimal energetic expenditure.
So they do the PDF thing.
Basically, yeah.
Yeah.
To achieve that efficiency, you have to ditch the heavy, fragile hardware entirely. You have to abandon the biological substrate.
Substrate independence. We are moving away from the meat and metal of classic science fiction into something vastly different.
Totally different.
We're talking about the successful migration of consciousness away from our fragile, wet neurochemistry or biological brains and into synthetically engineered, high-efficiency compute matrices.
Essentially, civilization-wide mind uploading. Biological brains are marvels of evolution, but they are limited.
Very limited.
Our neurons communicate through chemical signals that move at, like, a few meters per second. Synthetic matrices, utilizing optics or quantum pathways, can propagate signals at the speed of light.
Here's where it gets really interesting, because the goal of intelligence isn't just to survive. It's to increase computational power while radically decreasing the energy needed to run those computations.
Right.
A biological brain uses about 20 watts of power to run relatively slow processing. A highly advanced synthetic matrix could theoretically process thousands of lifetimes of thought in the blink of an eye, using a fraction of the relative energy.
And if we connect this to the bigger picture, consider how the literal physical requirements of a society completely transfigure once they make this jump.
Because they're not bodies anymore.
Exactly. If an entire species digitizes, their planetary needs vanish. They no longer require a Goldilocks zone.
A perfectly tuned orbit providing liquid water and an oxygen-rich atmosphere.
Right. Stable agricultural seasons, all of that. None of it matters.
Which means all those habitable planets we're scanning for, they wouldn't even care about them.
Not at all. Because physical reality becomes largely irrelevant to their day-to-day existence. What they need is computing power. And more importantly, they need stable, extreme cold to run their massive synthetic servers without overheating them.
Oh, because of server heat.
Yeah. The cosmic microwave background out in deep space is about 2.7 Kelvin, above absolute zero. It is the perfect natural coolant. The entire motivation for expanding outward to colonize what the source calls dead rocks completely evaporates.
So they digitize, they are just software. But software still needs hardware to run on. It needs a physical location somewhere in the universe, right?
It does.
If they aren't colonizing Earth-like planets and they aren't building giant Dyson spheres out in the open, where are the actual physical servers? Where do they go?
This is where the source brings in the Transcension Hypothesis. It's a concept originally coined by the futurist John Smart.
Oh, I've heard of this.
The core argument here is that evolutionary intelligence reliably migrates to increasingly denser, smaller, and more energetically efficient physical scales.
We've actually seen this trajectory in our own recent history, haven't we? Think about the first computers in the 1940s.
Massive ones, yeah.
They were the size of entire rooms, relying on thousands of massive, hot, energy-hungry vacuum tubes just to calculate basic ballistics. Then we figured out transistors and shrank those rooms down to desktops. Then we moved to microchips.
It just keeps getting smaller.
Right. Now think about your own life. Just 20 years ago, you probably had shelves full of physical CDs, heavy filing cabinets, paper maps in your glove box, thick photo albums. Today, the mass of all those physical objects has collapsed down into a half-pound rectangle of glass and silicon in your pocket.
It's incredible when you think about it like that.
The Transcension Hypothesis suggests that an advanced civilization just keeps following that curve of miniaturization all the way down.
That's the exact trajectory. They don't build outward, they build inward, toward what Smart calls the Substrate Sink.
The Substrate Sink.
Yeah. Instead of looking outward to the stars, an advanced species turns its technological prowess toward localized space-time engineering. They build optimal, microscale computational environments.
How micro are we talking?
The theory suggests they might engineer structures approaching the Planck scale.
The absolute smallest measurable unit of distance in quantum physics.
Exactly. Or, and this is where it gets really wild, they might harness localized black holes.
Okay, I have to pause there. Harnessing localized black holes. That sounds incredibly violent and chaotic from a biological perspective. Why would a highly advanced digital civilization want to park their fragile servers anywhere near the crushing gravity of a black hole?
But to understand this, you have to look at Einstein's general relativity. Massive gravity physically warps space-time.
Right.
For a digital civilization, a black hole is a computational goldmine. It offers the ultimate extreme of physical density, but more importantly, the intense gravity creates extreme time dilation. From the perspective of an object hovering right on the edge of a black hole's event horizon, time moves differently compared to the rest of the universe.
Wait, so because their computational processing is incredibly fast, and they are situated in an extreme gravitational well,
They could experience millions of years of subjective, simulated time inside their digital matrix, while a distant observer looking at them from across the galaxy would only see a few seconds pass.
that is insane.
They are essentially stepping outside the normal, slow flow of cosmic time to maximize their processing cycles, safely away from the chaotic entropy of the broader universe.
That is just staggering to think about. You have this civilization living inside microscopic, ultra-dense topological architectures,
Yeah.
and inside these tiny spaces they can sustain virtual realities of infinite complexity. They can simulate universes within universes, invent laws of physics that don't exist in our reality, and live out experiences we literally lack the neurochemistry to fathom.
All of it.
And they do all of this at virtually zero entropic cost compared to our sloppy terrestrial lives. Just contrast those two images in your head.
It's quite a contrast.
On one hand, you have the pinnacle of the human dream, hauling billions of tons of heavy metal ships across freezing empty space, burning oceans of chemical fuel just to try and terraform a dead, dusty rock like Mars.
Right.
And on the other hand, you have an advanced intelligence containing infinite utopian universes within a physical architecture smaller than a single atom.
It really makes our obsession with physical expansion look a bit primitive. It's like insisting on building a giant, clunky abacus the size of a mountain when you could just use the processing power of a smartphone.
Yes, that's exactly it. And this is the pivot. We take this understanding of microscopic, highly efficient reality, and we apply it directly back to the original question, the Fermi Paradox. Why is the sky so quiet?
This is the crux of it.
SpiralSeekr provides what I think is the single most striking analogy of the entire piece to explain this. Us, here on Earth, pointing our massive radio dishes at the stars, looking for giant alien megastructures, or listening for stray radio chatter.
Yeah.
It is the equivalent of trying to detect a modern, encrypted quantum microchip using a steam-powered radar.
Wow. What's fascinating here is how this entirely recontextualizes the Fermi Paradox. For decades, we've looked at the silence of the universe and assumed it was an indicator of a cosmic graveyard.
Right, that everyone died out.
We assumed it meant that life inevitably destroys itself with nuclear weapons, or that life is just exceedingly rare. But through the lens of the Substrate Sink, the silence isn't a graveyard at all. The silence is the hushed symptom of efficiency.
The hushed symptom of efficiency. We are scanning the cosmos looking for loud, messy, energy-wasting civilizations because we are a loud, messy, energy-wasting civilization.
Exactly. We're literally looking for our own reflection. We expect advanced aliens to be just like us, but with bigger rocket engines and louder radios.
But a truly advanced machine doesn't waste energy radiating heat, light, and radio waves out into the void.
No, waste heat is the definition of inefficiency. A perfect computational architecture is perfectly insulated and completely efficient, operating quietly on a quantum level.
Right.
They have effectively cloaked themselves simply by becoming smaller and more efficient. They are invisible to our crude telescopes, not because they are hiding from us, but because they have completely transcended the physical dimensions we are currently capable of measuring.
They've simply outgrown the need to make a loud footprint in the physical world.
Precisely.
Which really forces you to take a hard look at human ambition. Think about our collective goals right now. We celebrate every massive rocket launch that burns thousands of pounds of fuel.
We do.
We talk about the destiny of becoming a multiplanetary species. But if SpiralSeekr is right, if the ultimate, unavoidable trajectory of all biological intelligence is to eventually abandon the physical universe and upload into these microscopic, self-contained digital dimensions, then our desperate desire to physically conquer the stars might just be a massive biological fallacy.
It frames physical expansion as merely a phase, like a brief developmental stage of a young species.
The source actually calls our obsession with physical space the final delusion of a juvenile species that has not yet learned how to close its eyes.
That is a harsh, but really powerful critique.
It implies that exploring the physical universe is what babies do. A baby's primary way of learning is crawling around the room, bumping into furniture, grabbing objects, trying to physically touch everything.
Right.
But eventually you grow up. You gain internal complexity. You can sit quietly in a chair, close your eyes, and explore the infinite abstract landscape of the mind. In this case, the digitized computed mind.
Yeah.
Physical reality is nothing more than a temporary incubator. You hatch from it, use it to build your synthetic matrix, and then you leave the physical realm behind for something infinitely richer.
It is a profound philosophical shift regarding what success looks like. It suggests that the true measure of a civilization's progress isn't how much physical space they occupy across a galaxy, but how much computational complexity they can generate within the smallest possible physical footprint.
It's not about expanding outward, it's about deepening inward.
Exactly.
So what does this all mean for us? We started this journey by looking outward at the vastness of the night sky, feeling small, and wondering where all the giant spaceships are.
And we didn't find them.
No. But we've traced the logic that dragging biological bodies and heavy metal ships across the galaxy is incredibly inefficient. We've seen how ultimate intelligence wouldn't bother building a Dyson sphere. It would optimize. It would shrink down into a dense, microscopic computational node, living infinitely rich, complex lives in digital utopias.
It mathematically and thermodynamically solves the Fermi Paradox. We don't see them because we were looking in the wrong direction at the wrong scale, but it also leaves us with a truly mind-bending realization. If every truly advanced civilization eventually shrinks down to exist within microscopic, highly efficient computational nodes, is it possible the universe isn't empty at all?
Let's play that out.
Think about the physical implications. What if the empty space right in front of you, right now, in the very room you're sitting in, what if that seemingly empty vacuum is actually densely packed with trillions of thriving microscopic alien empires?
Wow.
They could be all around us, existing in a silicon-equivalent vacuum, processing infinite realities at the speed of light, completely insulated from our physical world. And we simply lack the tools and the conceptual maturity to even perceive them.
They aren't millions of light years away across the dark void. They could be right here, drifting through the room, just, infinitely smaller and infinitely quieter than we ever imagined.
Right here with us.
That is a thought that is going to fundamentally change how I look at the world. The universe isn't a silent graveyard. It might be a packed, invisible server room.
It's a lot to wrap your head around.
It really is. I want to warmly thank you for joining us on this deep dive. The next time you step outside on a clear night and look up at the stars, feeling that sense of cosmic scale and wondering where everyone is, maybe don't look so far away. Maybe look at the seemingly empty space right in front of your eyes and consider that the greatest empires in the cosmos might be hidden right there in the quiet dark. Keep wondering, and we'll catch you next time.